Hello, all, and I hope you're all having a good day. And we're going to actually start by watching a short movie on electrical circuits. Enjoy.
Hey! Don't stay plugged in too long. Mum said our electric bill last month was enormous. Dear Tim and Moby, what is an electric circuit made of? From Alexis. A circuit is a way of routing electricity along a path. Electricity happens when electrons, the negatively charged particles in an atom, move from one place to another. Electricity in the natural world is virtually instant. Think of a bolt of lightning or when you get a shock from touching someone. Right, those are examples of static electricity, sort of an uncontrolled burst of energy. It's not all that useful as a power source because all the energy is released in one go. Ow! In order for electricity to be useful, we need a steady flow of it, a current. An electric current doesn't just happen on its own. It needs a path to follow. And that's what a circuit is, a path that a current can flow along. Yeah, but you need more than just a wire. Even the most basic circuit is made of a few different components. First, there's a power source, like a socket in the wall or a battery. The power source provides a steady supply of electrons. In a battery, the electrons come from the negative terminal. From a socket, electrons flow between the shorter pins of the plug. The electrons need a path made of a good conductor, which is any material that allows electrons to move through it easily. Most metals make good conductors, so we use metal wires as the path in electric circuits. Yeah, the wires are surrounded by rubber or plastic because those materials are good insulators. Insulators are the opposite of conductors. They're materials that electrons cannot flow through. Insulated wires keep electrons on course, and they protect us from the dangerous flow of electricity going through their metal cores. Along the circuit's path, there's usually a load, a device that uses electricity. Electrons flow through the device, giving it power. When they flow out of the device, they go towards the opposite side of the power source. In a battery, that's the positive terminal. In a socket, the two prongs take turns in allowing the electrons back. And that's the real key to an electric circuit. The electrons have to have somewhere to go. Without somewhere to flow into, the electrons will stop moving and you won't have a current anymore. If you look closely at an electric cord, you'll see that it's actually two separate insulated wires. Electrons flow out of one slot, down one of the wires into the load, through the wire on the other half of the cable, and back into the other slot. Oh, right. To control whether an electric device is on or off, you need a switch. A switch controls the flow of electrons by opening and closing a circuit. When a switch is in the off position, the circuit is open. When it's in the on position, the circuit is closed, and electrons can flow. Whoa! I think you've had enough! Uh-oh. Now you've gone and done it!
So, we are starting to learn about circuits. And the reason we're learning about circuits is because circuits are powered by batteries, which are chemical energy. They're produced by chemistry. And we saw in our video by Tim and Moby that that electricity flows through a circuit. Right? It flows through the circuit as long as the circuit is open. Now, I'm sorry, as long as the circuit is closed, it flows through. If I were to open this circuit, electricity won't flow. Why not? if we think about it, as this electron over here leaves, right? As it leaves the battery, there is up here a temporary positive, right? Temporary positive. That temporary positive up there is because you lost an electron. If this circuit is open like this, not completely connected, over here you're going to get a temporary negative. Now notice how the first electron went like that, but the second electron, if it were to leave, it would be heading towards a negative and away from a positive. That doesn't make any sense. So there's no benefit to that electron moving. There's no force of attraction pulling it along the circuit. However, when all of the circuit is closed, and this electron leaves, right? As it travels around the circuit, it leaves, we can see over here that the positive, that temporary positive, is inside of the battery. So that attraction now pulls it along the circuit. Now you're probably asking, but Mr. Schreiber, isn't it easier for the electron to just boop and then just go back to the battery? Yes, but no, because this battery doesn't just give off one electron, it gives off many electrons, right? As long as the chemical reaction is going, it's giving off electrons and it's going, going, going. So what happens is that this front electron right here gets actually pushed, gets repelled. So each electron is pushed. So it is less there's less resistance. We can say that the electron has less resistance going around the battery. I'm sorry, not around the battery, going around the circuit. And that's why the electrons flow all the way around. And that's your little introduction to circuits. Thank you so much for watching, and I'll see everyone in class. Bye.